Julian, you can't. And they're like, Julian, I've never heard of that brand of vacuum. I think it's a Dyson.
Yeah. Knowing me, it'll be a dirt devil.
Hello and welcome to That's Absurd. Please elaborate. I am Trace, and this is our podcast. It looks, you could see it. I know, it's amazing. Anyway, in every episode of our show, we answer an off-the-wall, strange, out there, ridiculous question from our listeners, or now our viewers. And we do as much research as we can and figure out what the science says about that ridiculous question. In every episode here on our YouTube channel, you're going to get one question from an episode. You'll be able to listen to the whole episode over on our audio feeds if you want, and we'll package them together into the full episode once all of them are uploaded. In the meantime, though, Julian, what's your question?
Julian Huguet, that's me. I'm the other one. The other science communicator for this science communicating podcast. Is that our crutch word? So Annie Mouse asks, what part of the human body is the most heat tolerant?
Is Annie Mouse some kind of torturer?
I was going to say, the fact that it is anonymous and it's also like, what part of the body?
Excuse me. Hello. I have a question. For the podcast. If I were to drive a nail through a part of the human body, what part would be the most painful? I'm asking just for reasons. You don't need to know the reason.
For science, of course. Well, yeah, I was going to point out, I'm very glad that it wasn't, the converse side of that, of like, which part of the body is the least heat tolerant? Where can I do the most pain with the application of heat? No, so hopefully, we're not aiding and abetting anybody nefarious.
Let's hope not.
Annie Mouse elaborates, I heated some pie in the... they typed air dryer. I'm going to assume they meant air fryer.
I mean, maybe they have no idea how heat works, and they literally did put their pie in an air dryer, and were like, this isn't cooking.
or held up a hair dryer, and they're like, a blow dryer. Come on, pie.
Come on,
anyway,
pie.
Annie says, they couldn't lift it out with my hand because it was so hot, but I could eat it just fine. So I originally wanted to ask about hands versus mouth specifically, but started to doubt myself and decided to ask this more general question instead. And then, to make it clear that they are not, again, a torturous, murderous individual, they punctuated it with a smiley face. So we know it's fine.
Yeah, so it's fine. It's definitely all fine. You put a smiley face at the end, it's all fine.
Just hanging out.
Emoji.
Hey, get in my windowless van. Winky face. Like nothing bad happening over there.
Do you have candy? No.
Well, I don't get into windowless vans for anything less than full bars. Not even fun size Snickers. No way.
Ugh. And what is the? Okay, we're recording this not long after Halloween. I do have a kid. What's the size smaller than fun size? Because when I was a kid, fun size was like oh man. And now they have like the tiny cubes that are like 1 centimeter of candy, 1 cubic centimeter of Milky Way.
Oh, okay. Well, on the fun sizing question, to take a totally unrelated tangent.
Yeah.
Is it like the smaller you get, the more fun it gets? Or is it
that's the implication?
I have more fun when I get a larger bar. Like, I don't look at a full size bar and go like, wow, that's serious. I'm like, this is better, right?
This is gonna be great.
It's always like king sized.
Yeah.
So I guess fun size is like jester sized. So then maybe it's a royal court.
And so that would be more just like lord sized, just the little cubic centimeter. Surf sized? Surf
sized.
Surf sized.
SERF. That's the portion Aaron Aronson gets when he goes trick or treating.
Oi! Oh, we got a larger Mars bar, please.
Oi!
This is too small. It is just 1 cubic centimeter of chocolate. Please more. Please,
my boy has the plague. Let him taste something delicious before he goes. Also, what's chocolate? Because he's from before the Europeans learned about, the new world, quote unquote. So yeah. Very surprising. Yeah. Any size chocolate back then would be fit for a king.
To be honest, true. Yeah.
Yeah. That all had nothing to do with anything we're about to talk about. So Here we go.
Again, if this is your first time, thank you for listening to this podcast.
That was a test. You passed.
Now that all of the new people have left.
now we've weeded out the normies. Okay. This made me think of that tweet, though. I think it went viral where somebody asked, like, do you blow on your food to cool it off, or do you just that until you can eat it? Which I felt very relatable to me. But I started thinking first off about, what any part of the body that's most heat tolerant. And my mind immediately went, of course, to your bones, right? And it went to specifically like cremation because I'm a bit morbid. Yeah. And I also watched that ape crazy or chimp crazy docuseries about how they tried to cover up the death of a chimp. Like they faked the death of a chimp and then they had like some ashes. It's a crazy documentary. I won't get into it. But anyway, some people who illegally had a chimp tried to say that it died and was cremated.
What?
And I was watching it like, there's no way. But anyway.
What?
Watching that led me to like look up some things about cremation. Like, do bones not turn to ash when they get cremated? And it turns out, a lot of bone fragments stay behind. So the cremation ovens are like 1,400 to 1,800 degrees Fahrenheit, or about 800 to 1,000 degrees Celsius. And at those temperatures, the soft tissues turn to ash like you would expect. The bones, though, calcify. They don't just fall apart. They might break up into smaller pieces, but you'll still get these little bone fragments. So, hot tip for all you murderers out there, you still have to like grind up the bones. At a crematorium, they have a machine called a cremulator, which they use to grind the large pieces of bone down. So it's like a sand-like consistency. And then, you can have your little urn of your beloved, consistently ashy, sandy, like smaller, fragmented former loved one, and rest in peace, knowing that they're all
so sentimental when you put
out.
It that way.
I know. It's weird. I hope if they cremate me, I hope they leave the bone fragments behind. So if somebody tips over the jar, you'd like have to pick up some larger pieces. Anyway, but looking at Annie Mouse's,
you just have to vacuum you off the floor. And then the vacuum becomes the urn.
The vacuum is the urn?
And then you just hang the vacuum on the wall and people are like, oh, you spilled something. Let me go get your vacuum. And you're like, no. That's Julian. You can't. And they're like, Julian, I've never heard of that brand of vacuum. I think it's a Dyson.
Yeah. Knowing me, it'll be a dirt devil. Okay. So then I realized that that's not really what Annie Mouse is asking, right? They're more talking about like sensation when you're touching things. What is the most heat tolerant, right? Because when you have hot food and it's like burning your hands, but then you just shove it in your mouth, and you it may like feel more tolerable, but it can still burn your tissues, right? You can burn your palate, you can get blisters on your cheek, on your tongue. So it's still doing damage, but for whatever reason, you're perceiving it like it's more tolerable. So I did some digging onto what could be possible explanations. My first thinking was about just how sensitive our hands are in particular, right? Like when we talk about nerve endings and where they're concentrated in our body, these different nerve endings that help us feel sensations, there's a ton in our hands, and particularly in our fingertips, which makes sense, right? We use them a lot to perceive the world around us. So I thought that might be some possible indicator of it. But of course, there are a lot of different types of nerve endings. The ones that we're interested in have to do with sensing heat. And so I looked into that, and there are specific nerve endings that have to do with different temperature ranges. For example, there's a receptor called TRPV1. It stands for Transient Receptor Potential Cation Channel Subfamily V for vanilloids, number 1.
Wow.
And it's sensitive to temperature, which is thermoception, but it's also sensitive to pain, nociception, right? And the way this protein works, basically, it's a complex protein that's like in the cell membrane of your skin cells, and it gets deformed in high heat. And when it does that, it sends a signal through your nerves to your brain and you sense that heat. But it also can be triggered by molecules that are released when other skin cells get damaged, say something like hits your skin, pierces your skin, it destroys some cells. These cells, as they burst, release everything inside of them. And some of these trigger the TRPV1 receptors, and that sends a signal to your brain as well. And so you interpret that as pain.
That makes total sense, though, because you would want to know if your cells are being bursted.
Yes, damaged, or if the heat of something is enough to damage your cells and you need to quickly recoil your hand from the hot stove or whatever, right? So it's not only the temperature sensing, but also the, that hurts sensation. Yeah. Another thing that can trigger it, I mentioned that the V in TRPV1 is for vanilloids. You know what one particular very famous vanilloid is?
Capsaicin.
Yes!
I have a whole talk about this.
Good.
And it's why we have spicy butt.
That is, yes, that was not the particular phrase I was going to use, but yes.
That's why we have spicy butt.
Okay. Capsaicin is the molecule that you find in like chili peppers, and it triggers this TRPV1 receptor, and that's why spicy hot and temperature hot can be kind of conflated, right? The chili pepper isn't over 43 degrees Celsius, which is how hot it has to be to trigger these TRPV1 receptors, but still causes that burning sensation.
And your body doesn't know.
You're just working, with the best input that you can get from outside stimuli. Like, it's, sometimes things get conflated. So you also have receptors that are sensitive to cold, like TRPM8, and TRPM8, along with low temperatures triggering the nerve response, also can be triggered by menthol. So that's why you get that cooling sensation. Yeah. Very cool.
Cool butt.
So
I don't think people eat enough menthol to get that.
The only cure to spicy butt is... What, Trace, do you want to explain what you're talking about when you say spicy butt in particular?
Fire poops.
Right. But
spicy butt.
You're right. You gave a talk on this, apparently?
Yeah. I did a nerd night on it.
Oh.
Yeah. Because I wondered why our butt could taste spicy food.
So
Which really is a question for this podcast.
It is, but we've already answered, apparently.
Yeah.
Okay. So I thought maybe, the fingers have more TRPV1 receptors or something like that. But no, they're also jam-packed in our mouths as well and on our tongues. Our tongues also have a lot of nerve endings, which makes sense because, they feel the food that we're eating, the texture, and obviously the flavors based on the molecules present in the food. So I don't think it can be put down alone to saying, well, our hands have just more of these nerve endings and therefore they're more sensitive to heat. But I couldn't really find any research that went into it as to why, right? Why when you shove something hot in your mouth, it seems more bearable. I do have some potential explanations that I found or that I thought of that I think are reasonable, but I couldn't find any dedicated studies to it. I think, first of all, you've got your mouth is at a higher temperature than your hands, right?
Yeah.
It's inside your face with the mouth closed. It gets warm from, the biological processes, so it heats up to body temperature.
Like closer to your basal body temperature.
Yes, whereas your fingers are touching the air that's, around room temperature, most likely. So maybe because there's less of a temperature difference between your hot food and your mouth than your hot food and your fingers. That's one reason that maybe doesn't seem as bad. You have saliva in your mouth, which can absorb some of the heat of your food, right? As it soaks up that energy from your food because a lot of it's water. You've got airflow from breathing, right? So you're kind of like fanning it as you go, right?
Yes.
And some of that heat is being absorbed by the air that you're passing over it and being carried away. You're also moving the food around in your mouth so it doesn't sit in one place for as long, right? If you've got a hot potato, let's say, and you juggle it from hand to hand, you can withstand it longer than if you're just holding it
Holding
until
onto
it burns your fingers.
Right.
And of course, when you take a bite of something, you're just taking a little bit of that hot thing. So it's easier for your mouth to cool it down. It doesn't have to absorb all the energy in the whole thing of food than when you're holding, I guess, your entire pie out of your air fryer.
Air dryer.
Air dryer, right. I did find a 2007 study from the Journal of Sensory Studies on why coffee doesn't burn the mouth. They said that they actually monitored the coffee temperature with thermocouples in the cup, in the coffee bolus, in the oral cavity, on the surface of the tongue. And they found that there was minimal cooling as the coffee went into the mouth. And the coffee temperature was still above the threshold for inducing burn damage. So they hypothesized that during drinking, the bolus of hot coffee just isn't in your mouth long enough for it to heat the epithelial surfaces and cause pain and tissue damage. That was it. So basically, because you're just because you're just slamming back the coffee, you're like, it burns, but not very long, so it's fine.
Huh. That explains why then you burn your mouth with pizza. Because that stuff's in there for a minute, and it's like cheese holds a lot of heat. Anyway.
Yes, as we learned from our moon cheese episode.
Yeah.
Right, it can get quite hot. So I hope that answers the original question that Annie Mouse thought of, why can I shove it in my mouth and it seems okay? But I wanted to also look, definitively, can I find any research on the most heat-tolerant part of the human body? And Trace, would you believe it? I found a paper on this.
Oh, I mean, I would believe it. There's a lot of papers out there, but
there are
a
lot.
Good paper? Is it
Now that's the thing. Reading it in my unexpert reading, I don't know how convinced I was in their findings, but I will get into that. So this paper was from January of 2020. It was from researchers at Cal Berkeley, and they wanted to map out the thermal sensitivity of the entire human body. And this is because they are working on, quote, personal comfort systems. Basically, just like some clothing that you can wear that if you're cold, it'll heat just you up. And the idea is this way you don't have, like in a big office building, to set the temperature to something higher that would use a lot of energy or colder, whatever the case may be. You just wear some personal clothing. And if you're like, I'm feel a little chilly, you just dial it up on yourself. And then, people in the office don't have to fight over the thermostat, that sort of thing. Yeah. So it saves energy, hopefully makes everybody get along in an office workspace. But in order to know, all right, how should we design these to be most effective, they wanted to actually measure the different heat tolerances across a person's body. So they had over 60 people come in, men and women, college age. They controlled for like different sizes typically. So they selected like larger than average women, smaller than average men. And they probed them with little...
Whoa.
Sorry. That sounds more intense than it was.
Wow.
They just stuck a little, thermal probe on different parts of their body. They tested 318 spots. They would either warm this probe up or cool it down, like plus or minus 5°C. And then they asked the participants to rank how hot they perceived this change to be. Was it really hot? Is it not noticeably hot? What was it, right? And I have included, I just sent it to you, the map that they made
so excited.
Of the sensitive regions of your body to different temperature changes.
Whoa, what a booty.
Yeah. Well, specifically, Trace, what do you notice about the booty?
It's got, yes. I just, in my mind, when I first saw it, I was like, there's a shadow underneath the buttock, which makes sense because that is a badonkey one. But that would be a very sensitive temperature area.
Yes.
Both for cooling and for warming. How interesting.
According to this study and the data they got, the most sensitive part of the body is basically right under the buttock.
Yeah, like the butt crease.
And I don't know why that would be the case.
Yeah, that is very strange.
Just kind of the area if you're having like a really intense makeout sesh, like where someone would grab you, Yeah. Does that help elucidate the region I'm talking about, listener? I sure hope so.
I hope so.
Anyway, now, about this paper, about this study. Again, They worked with over 60 people, but they broke them up into 3 groups, I think likely so they didn't take up all their time, like going over all 318 spots on every person, So
Yeah.
it was really more like 15 people per sex, per group, thereabouts, that they probed, which I don't think is a huge sample size. And the fact that the scale that they used to rank the sensitivity was very subjective also makes me wonder if that might confound this. I have a theory that because they were probing under the buttock, which is quite a private area, that unless, you're doing a hardcore makeout sesh with somebody that normally I don't want anybody to touch, I feel like probing me there would make me more acutely aware.
Agreed. That's exactly what I thought.
The great. I'm glad.
It's not, I don't think that it's actually, I agree with you that I'm skeptical. I don't think it's actually that area is significantly more or less sensitive to, or like more sensitive to hot or cold. It's just that area of the body, that like under butt, isn't exactly typically stimulated in many ways, right? Like you're not sitting on a chair and that part of your body is all of a sudden twinged, It's just like that is a part of the body that is, as you say, more intimate. And so that's when it is touched, that does also, just to counteract my own argument, maybe that's why it is more potentially temperature sensitive, because it doesn't get as much interaction directly.
Yeah. Well, speak for yourself. I don't know about you. Well, I almost wonder, though, because, it's like a researcher probing them with this temperature, like, probe, if that made it more awkward. But if they were to sit on, like, a heated seat or something and get warmed up the same way, would they rank it as, less sensitive? I don't know. But fortunately for us, that's not really what Annie Mouse was asking about. It was what's least sensitive. And that I think is more believable based on these graphs that we have. And it is like the shoulder area, kind of the top middle of the chest, and then what I suspected from the get-go, which would be the feet, the extremities.
The feet, yeah.
Bottom of the feet. That makes a lot of sense to me, right? That is a part of your body with some thick skin. It's got to walk over, rough terrain or like hot or cold, right? It's probably more suited for touching high temperature stuff longer than the rest of your body. So that, to me, I think would have to sort of be the answer. Like things that you can tolerate physically, right? Not like if you put me in a cremator and what's left, my bones. Things that I can touch onto a hot thing for an extended period of time and still feel pretty okay with it. Probably going to go with the bottom of the feet. Now, in a slightly related note though, right? If you are having a hardcore makeout sesh, right? Before you get to your air fried pie, right?
Yeah.
With your significant other, right?
Your air dried pie.
Your air dried pie, and you wanna particularly make things real hot. We now have a published peer reviewed chart of the place that gets hottest when you're stimulating, and that is under the buttock. So
under the buttock.
The place.
However, if you don't want to go all the way to the to third base, I think it's called, you could go midway, and around the ribby area seems to be kind of nice. It seems that seems okay.
Yes, we'll publish the chart on our Instagram. So if you're using hot or cold jellies for whatever reason. Anyway, well, Trace, now you can add a corollary to your spicy butt talk. Like, hey, not only can your butt taste spicy, but also it feels the heat probe the most.
Look, I didn't realize I was going to get more fodder for my conflagulatory buttock talk, but here I am, learning things all the time.
Yes. Glad to add, this is what science is. We're building a foundation of knowledge, right?
Correct. We're starting at the bottom.
That's great. Well, Annie Mouse Anonymous, I hope that answered your question, and you can get back to cremating that body or whatever it is that you're doing.
We're not asking. We're not asking.
We're not asking the questions here. What are we, cops? Not.